Next speaker is Stefan Grasböck. He will talk to you about how to eliminate side effects in developing software projects. Clear the stage for Stefan Grasböck.
Hello and welcome to my presentation. My name is Stefan Grasböck and we are Fusonic. Today I want to talk about how to eliminate side effects and call third-party services reliable and without direct implications on the current transaction. First of all, we are going to state the problem that we want to solve. Secondly, I want to give a very brief and short description about the CQRS pattern. Furthermore, I want to explain what the mediator pattern does for us. After that, we come to the solution of the mentioned problem. I will show a quick overview and the core examples of code that are going to be important. To further solidify our understanding, I will demo the solution within a project which you will be able to download yourself for further investigation. And last but not least, I want to summarize about what we have talked today. So now let's get started. Fire and forget how to eliminate side effects. So what is the problem that I want to talk about today? Well, it is something I already hinted and something that most developers have faced in their career or will face eventually. It is about dependencies. Applications typically don't operate in their isolated bubble. So almost all applications need to communicate with one or many other services. Some common interactions with third-party services could be sending an email or an SMS, notifying other services and or calling into other services, background processing of compute-intensive data. So what do they all have in common? So each call to an external system or service should happen reliably, but it is usually neither required nor technically possible to call the other services atomically within the current business transaction. So as a result, when not handled properly, lots of subtle issues can occur, which might lead to an eventual inconsistent system. This code can demonstrate this. So what happens here is that we have a register user handler, which creates a user, adds it to the current context, and then saves the changes of the context. The email sender send async is called then, which basically just creates an SMTP client, sets up an email message, and sends the email. So what can go wrong here? Well, the happy path is when save changes executes correctly and email sender send async also returns correctly. So everything is good. The user is saved and the email is sent. The consistent error path would be when save changes fails, the user is not registered, and no email is sent. This is not good for the user experience and an error page will appear, but at least we return to a consistent state. The problematic error path would be when save changes succeeds, but email sender.send async does not succeed and it fails. So this is not good for the user experience because an error page will appear. The user gets registered, but he does not receive an email. So he is in the system, but he doesn't know that he is. The fourth error that can occur is if save changes succeeds, but the auto transaction of the request rolls back. So what actually happens is the DB context save changes succeeds, email sender send async sends the email, but the ambient transaction which encloses the DB context save changes async rolls back. So also the changes of this transaction are rolled back. So the user is not saved in the database, but he got an email that he is registered on the site. Before we talk about how we can solve this problem, I want to refresh some key practices and patterns. CQRS stands for Command and Query Responsibility Segregation, a pattern that separates read and update operations for a data store. The mediator pattern promotes loose coupling of classes by removing direct dependencies. It can also simplify communication in general when a program contains a large number of classes that interact with each other. So how do we tackle this solution this problem that I mentioned before. So the solution is a reusable outbox pattern, and what an outbox pattern is what I want to show you here. So we have the register user command handler, and whenever that succeeds in registering the user and saving it to the database, it saves with the same transaction, it saves a send email job to an outbox. This could be, for example, a simple table where a job is stored, send an email to this user. And this all happens in one transaction. So if the user is not changed, also the send email job is not saved to the database. Our outbox processor then, in a second transaction or in a second flow, fetches the data from this table and processes these jobs and eventually sends the emails. How can we make this code reusable? So we can use Hangfire as our job processing queue. Hangfire stores the job in its own database scheme and can be set up to even automatically retry whenever a job fails during execution. Decorators allow us to add to the current behavior of a class. By decorating the requests that we want to execute outside of the current flow, we spare us to create, for example, a Hangfire send email or an Hangfire notify admin. So we can decorate both of these requests with a Hangfire decorator, and we save us a lot of boilerplate code. We can also rely on the dependency injection container pipeline to resolve our decorators, as this is deterministic, for example the simple injector. In C#, it is pretty easy to mark an interface or a class by an attribute, and with this we basically mark it to be decorated. So how does this work? We have our DI container here, which has two requests, request A and request B and request A. And request A is marked with an attribute. So whenever we call register decorator for all T requests, so for all requests of this type, which are marked with an attribute, the dependency injection container then looks as follows after that. Request B is unchanged because it was not marked with an attribute, but request A got decorated with the decorator because it was marked with an attribute. How does this look in our concrete example? So we have the request B and we have the user registered example, the user registered request, and the user register request is marked with an out of band attribute. So I call then register decorator for all T requests marked with an out of band attribute. And dependency injection container looks as follows. We have request B and we have the T decorator of user registered with the decorated request here, and it's still marked with the out of band attribute. So now on to the demo. So what this code here shows is very similar to what we have seen on the slides. I want to show you the startup class before, which calls container register out of band decorators, which is an extension method provided by a Fusonic NuGet package that is open source. So register user just gets just is a command basically with an email name and a surname, and it creates the user, adds it to the current context, and saves the changes. After that, it calls mediator.publish, and mediator.publish just basically calls an event of user registered, which then, for example, sends an email. So if we step into this, we can see the notification, the iNotification user registered, and this basically does nothing, but you can imagine that it could be sending an email. So we just log sending email to this user. So when I execute this, You can see we're using Swagger here, so I just click on try it out and I send the request, and we get the status code to 200 with the response, which is what we expected. So what happens now if I, for example, have the sending of the email fail? So I'm just throwing an exception here to basically make the sending of the email fail. So we expect 500 internal server error. Again, we try it out, we hit execute, and we already provided with the exception here. Click on continue, and we see that we got a 500 internal server error with the stack trace here. So how can we resolve this, that we actually can save the user when still the sending of the email fails? So we can achieve this with the out of band attribute. So this attribute here marks this notification to be decorated with the out of band decorator, which then allows us to execute, to apply the outbox pattern basically. So what I expect now is that we hit the exception, but that we still get response code 200, which is successful for storing the user. And we get it. We get a status code 200, and in a moment we will hit the exception. Yes, so we hit the exception here, and we can click continue. And if we look at the output window, for example, you can also see that it even has an automatic retry implemented with an exponential backoff. So this demonstrates how to apply the reusable outbox pattern for this problem. So implementing the outbox pattern on top of Hangfire is a nice and easy solution for solving these common service-to-service communication issues. Using our open source Fusonic extensions Hangfire integration package, you can easily plug a reliable outbox solution into your system. So if you're interested in learning more, David Roth, our head of development, has published the sample application that I just showed on GitHub. I hope we could provide you a good insight on how we tackle these problems. At Fusonic, we are constantly striving to be one step ahead and are therefore always looking for great people to join our team. We are currently looking for project managers, developers, designers. And if you're interested in how we work, please get in touch with me or visit our website fusonic.net. I hope you enjoyed this talk, and thank you for your attention.